Yes.
Yes, yes.
Yes, yes.
Okay. Now we discuss about what is substation, and we saw what are the main components of substation, like disconnecting switch, bus bar, circuit breaker, protective relay, transformer, CT, PT. These devices, how it is arranged in a substation. Last class we see a video of a person showing all the actual video of a visiting a substation. Now we are going to see in this lecture how these devices are arranged in a substation, and that arrangement of those devices in a substation is called substation layout. This is the picture of a substation layout. Here, this is a 230 to 110 kilovolt substation. This part is the high voltage side, 230 volt comes, and 110 lines going out. You can see many lines going out. There are three inputs lines coming. Remember, this one line in this diagram indicates three phases, actually three lines. Phase A, phase B, phase C, three coming like that. There are three input transmission lines coming here. All these three will be connected to a bus bar. Do you remember our lab? There are two bus bars, bus A and bus B. Similarly, in substations, some substation will be only one bus, some maybe two. So here you can see two bus bars. Two of them are not used always. At a time, only one will be used. But if something happened to one bus, then we will use bus two. It is like a spare. So all big substations all will have this double bus bar system. Then in that substation, you have two transformers which change 230 kilovolt to 110 kilovolt. So two transformers are working parallel. And for that, these two transformers are connected to these bus bars. So they are working parallel, then they are connected to this low voltage side bus. Low voltage side, instead of using two bus bars, in this we use only single bus. Only one bus is there. So it can be a two bus bar system, or it can be single bus bar system. So it's not strict like it must be a single bus bar or double bus bar. In the same substation, one side it can be double bus bar and other side maybe single bus bar system. Okay, this is an example of substation layout. We are going to see what are the different types of substation layout. So substations, based on its safety, as well as the reliability, the size of the substation, small and big like that, the layouts used are different. The simplest basic type of substation layout is called single bus bar system. It will have single bus on the high voltage side as well as low voltage side. Then there is a special type of single bus bar system with sectionalization, divided into sections. I can show you that example. Here it is single bus, one section, then the second section. There is a section divided into two pieces. Single bus is used, but it is divided into two sections. Then there is double bus bar system, like I show you in that previous diagram. There will be two buses. One bus is working at a time, and the other bus will be just as spare. This is the double bus bar system. Then there is double bus bar with ring bus. There is a special arrangement of ring connection. Then double bus bar with transfer bus. Actually, there will be three buses. Two bus plus one bus is for just transferring from bus A to bus B. Then there is a new system that is called 1.5 breaker system. This is name came from the number of circuit breakers used for operation. We will discuss it. And there is mesh system. There it is like a network. These are the main systems. Out of this, the four main types are single bus bar, double bus bar, 1.5 breaker system, and mesh system. These four we are going to discuss. Other are actually modification of single bus bar and double bus bar. Okay, single bus bar system. Here you will have only one bus, like you see here. It's not saying. Okay, this is the single bus. This is that single bus with section. You can see this one section, and these two are supplied by this bus. These two are supplied by this bus. But this can be closed to make it one bus bar. That is modified type. But basic single bus bar system will have only one bus. This is simplest and easy for operation. But the problem is, in case of a fault in the bus, the entire bus bar will be shut down and a lot of consumers will be out of service. Flexibility is minimum, least flexibility. That means a bus bar fault can lose of many feeders and many transformers. Coming to double bus bar system, this consists of two buses to which all feeders are connected. You have two buses. This feeder coming, it is connected to here as well as here. If you close this switch, it will be connected to bus 2. If you close this switch, it will be connected to bus 1. Every line going to transformer or coming to, this is from the transformer, other is from the supply transmission line, but all the lines will be connected to both. Not always connected through the circuit breaker, but one circuit breaker will be working at a time. The advantage is it provides better or more flexibility, better continuity of supply, and periodical maintenance of the bus is possible without total shutdown. I hope you did this in the lab, changing bus bar with the help of a bus coupler. Then there is a modified form. There is a double bus bar system with a transfer bus. It is again will give more reliability and more continuity of service. Now, one of the commonly used technique or one of the new technique in the substation is 1.5 breaker system. Here we use, it is not like this one. Here you are using this line to connect to this bus bar, and this bus bar you are using 2 circuit breaker. So each line need 2 circuit breaker to connect to bus bar. But here this line is connected to this bus 1, and this line is connected to bus 2. And between these two lines you put a circuit breaker. Here there is a here actually this box is a circuit breaker. So you have 1 circuit breaker, 2 and 3. So 3 circuit breakers are used to connect 2 lines. So totally to connect 1 line, you need 1.5 circuit breaker only. In double bus bar system, you have to use 2 circuit breaker for a line, but here 1 circuit breaker is reduced. Remember, circuit breakers in substations are huge and really costly. So it will save cost. Not only it will give higher security against loss of supply. So a circuit breaker can be switched off without for any maintenance work like this, and high cost system, but security is very high. This is the advantage of 1.5 breaker system. Now coming to the last one, that is mesh or ring layout. Here actually all the lines and all the transformers all will be connected to a bus bar system which is in a ring shape. Here the circuit actually this is just one loop is shown. It will be many loops, many networks together, so that the circuits can be tapped from any node. This is the node. This any junction can be connected to line or transformer, and other side of transformer will be connected to another mesh. Like this, different combinations of this transformer can connect to this, or this can be connected to this or this, and both of this can be connected to one, or both of them can be connected to two. Like this, any combination is possible. They are connected in a network format, and any type of power sharing is possible in this. So if some bus bar fault happens, it will cause loss of only one small section. All other supply can be adjusted through other parts. So circuit breakers can be maintained without loss of supply or protection. This is the advantage of mesh or ring system. And that's all about lecture 3.3, that is substation layout.